This lesson will be discussing vertical motion. So student learning objectives for this lesson: apply what we know about the quadratic equation to model vertical motion. Essential questions: what is vertical motion and how can we use quadratic equations to model it? And your Common Core standards are below. When discussing real-life scenarios, we mainly use quadratic functions to model vertical motion. This is also known sometimes as projectile motion. However, if you ever get to physics, projectile motion includes both the vertical component and the horizontal component of projectile motion. So if you were to launch something at a certain angle and it's going at a certain speed horizontally and vertically, that's more projectile motion. When we talk about vertical motion, we're more thinking about any object in free fall motion, so going literally vertically in motion. So something falling from a tree or something being shot straight up in the air, things like that. We're mostly looking at the vertical component of its movement. So what are some examples of vertical motion? So like I said, throwing a football up in the air, jumping off of a diving board and going straight down, going off a snowboard ramp, how long would it take to fall straight down? And any falling object, really, dropping something or something falling from a tree or the top of a building, anything like that. So here are some diagrams to show you some examples of vertical motion. Right here, dropping something, maybe off a cliff, throwing something straight up in the air. We may even look at throwing something not necessarily straight up in the air, but just focusing on the vertical component of how fast it's going upwards, and then how long it'll take to get back down to a certain point. And the same over here, we might even say, okay, what's the maximum height it gets to, or how long will it take to hit the ground, depending on other variables. You might say, oh man, that sounds very intense and confusing. Well, that's why we use quadratic equations to model them. Here below you see h equals negative 16 t squared plus vt plus h sub 0. Now that looks like a complete mess if it's the first time you've ever seen that, but it's a quadratic formula where t is in place of x, because usually when talking about vertical motion, we're talking about time. So a function of time, a function of in terms of time, and the function is going to equal h. What is h? H is the height of our object or anything in that vertical motion. So at a certain time, t, we can tell what the height of the object is. Now, what is this v? V is the initial vertical velocity. So for example, if we chuck something upwards, usually problems will give you an initial velocity. So I hit a ball into the air straight up at 10 feet per second. Okay, that would go here. This is our initial velocity, this b coefficient. Okay, and this h sub 0, the reason why this sub 0 is here is because that is saying when t is 0. So what is our height when t is 0? So what does that mean? Well, what's the height that the object starts at? For example, if I drop something off a cliff, let's say the cliff is 50 feet, well, that term goes right here. Okay, so it's starting 50 feet upwards instead of on the ground. Does that make sense? Now, this term right here, this negative 16, you might think, where the heck does that come from? It's actually, and you might learn this later on in physics, it's actually 1/2 the acceleration due to gravity. And when we talk about feet, the acceleration due to gravity is negative 32 feet per second squared. And that may sound very confusing to you. If you understand it, that's great. If not, just know that when you talk about a problem in the units of feet, your your vertical motion formula is going to have this negative 16 t squared to begin it. There's another formula when discussing meters. If a problem is in meters, the acceleration due to gravity is negative 9.8 meters per second squared. So half of that would be negative 4.9. So if you ever see something in meters, you would use negative 4.9 here instead of the negative 16. But most of the time, you will use negative 16 as your leading coefficient. And that's all I have for you for this lesson. I hope you enjoyed yourself. Hope you learned some things. Go ahead, try your homework assignment. If you have any questions, feel free to contact me on BBIM or by text message or email, whichever is easier for you. And make sure you come to live class and we'll go over some more examples. Thanks.